video, we'll have a look at the following combinatorics problem. Collection of subsets of all the numbers from 1 to n has the property that each pair of subsets has at least one element in common. Prove that there are at most 2 to the power of n minus 1 subsets in the collection. If you like, you can pause the video and have a go at the problem yourself before having a look at the solution. Okay, let's have a look at the solution. So I will make I'll denote A as the set of all subsets of numbers 1 to n, which contain the number 1. So these are all the subsets which contain the number 1. And B will be the set of all the subsets of the numbers from 1 to n which don't contain the number 1. So what you can see is we can divide all the subsets of numbers from 1 to n. You can divide them into two classes. So either they go into A or they go into B. So depending on if they contain the number 1 or not. So the sets A and B will form a partition of all the subsets. So, so we can now divide all the 2 to the power of n subsets of the numbers from 1 to n. So there are 2 to the, as you can recall, there's 2 to the n subsets of this larger set because there are n elements in the set. And we can divide them into 2 to the power of n minus 1 pairs. So what each of these pairs will look like is we have the first element of the pair is S and second element is T, where S is part of A and T is part of B. So this is what it looks like. So for each S in A, so for each subset containing the number 1, what we'll do is we'll make T the complement of the set S. So this denotes the complement of the set S. And we know that since S contains the number 1, then the complement will not contain the number 1. So this is what it says over here. So here's an example for n equals 3. So the 8 subsets of the set of 1, 2, 3 is divided into 4 pairs. So here we have on the left-hand side, each of these pairs contain the number 1, and the right-hand side is the complement of each set. So we see the complement of 1 is 2 and 3, the complement of 1, 2 is 3, and so on for these two as well. And we have an empty set here as well. So what we can see is that we are trying to select, so in the original question, we are trying to select subsets of the numbers from 1 to n. So each pair of subsets has at least one element in common. But what you can see here is in each pair, these subsets in each pair are completely disjoint, so you can't select both subsets in any pair. So what it means is you can only select at most one element from each pair. So that's because the sets S and T in the pair are disjoint. And since the number of pairs is 2 to the n minus 1, which is the same as 2 to the n divided by 2, this means that the maximum number of pairs we can choose will be 2 to the power of n minus 1. This is using the pigeonhole principle. Because if we had more than 2 to the power of n minus 1 pairs, 2 to the power of n minus 1 subsets, then by the pigeonhole principle, 2 of them must be in the same pair, which is a contradiction because 2 sets will have to be disjoint. That completes the solution to this problem. Hope you enjoyed the video. Thanks for watching, and I'll see you next time.